let's have a brief discussion on change of axis. Change of axis basically of two types fundamentally. One is translation of the axis, that means shifting the origin from 0, 0 to a new location without changing the direction of the coordinate axis. The second aspect is rotation without changing the origin. Of course, the third one, a slightly more complex one, is translation followed by rotation, which is called rigid body motion. So let's look at translation. If xy are the coordinates of a point P in the original coordinate system, and you shift the origin to a new point hk, and if these are the new coordinates, these are the old coordinates, then by simple geometry, x is equal to capital X plus h, y is equal to capital Y plus k. If you want the new coordinates, capital X is equal to x minus h, capital Y is equal to y minus k. So you can use this to estimate old coordinates from the new coordinates. You can use this to estimate the new coordinates from the old coordinates. When it comes to rotation, suppose we have small x, small y as the coordinates of the point in the old system and capital X, capital Y in the new system. Then you can use an orthogonal transformation to determine the coordinates of the new point. So in fact, you can build up your equation. Suppose you want to estimate the old coordinates, then you can use x cos theta minus y sin theta. These are the x coordinates, and y will be x sin theta plus y cos theta. Suppose you want to read capital X, capital Y, you have to see it column wise. X cos theta plus y sin theta and minus x sin theta plus y cos theta. So this is to get the old coordinates, this is to get the new coordinates. So if you can remember this orthogonal transformation, you can very easily solve problems on rotation. Question number 1. If the origin is shifted to the point 2, 3 without rotation of axis, then the coordinates of the point P, which divides the join of A4, 8 and B7, 14 in the ratio 1:2 or 2:1 with respect to the new system of coordinates can be, the options are 2, 5, 3, 7, 4, 9, 5, 11. Now let's analyze this problem. Now we have got 2 points A and B with original coordinates 4, 8 and 7, 14. And there's a point P which is dividing this line segment in the ratio 1:2 or 2:1. So therefore P will have two possible locations. So let us find out P1 and P2. Suppose you take the ratio as 1:2. Then 1 into 7 plus 2 into 4 by 1 plus 2, comma 1 into 14 plus 2 into 8 by 1 plus 2. This comes to 7 plus 8, 15 by 3 is 5, 14 plus 16 is 30 by 3, 10. So this is one possible location of P1. The second possible location of P2 is when we reverse the ratio. So now it is 2 into 7 plus 1 into 4 by 2 plus 1 and 2 into 14 plus 1 into 8 by 2 plus 1. 14 plus 4, 18 by 3 is 6. Then 28 plus 8 is 36 by 3, which is 12. Now these are the coordinates of P in the old system. Now we want the coordinates of P, that is P1 and P2, in the new system. So in the new system, P1 dash is equal to 5 comma 10 minus HK, that is 2 comma 3. This becomes 3 comma 7, and P2 dash is equal to 6 comma 12 minus 2 comma 3. This is 4 comma 9. You can find that these are available in options B and C. Question number 2. If the origin is shifted to the center of the rectangle with vertices 0, 0, 6, 0, 6, 4, 0, 4 without rotation of axis, then the coordinates of a vertex of the rectangle with respect to the new system of coordinates is. The options are minus 3, minus 2, 3, minus 2, 3, 2 and minus 3, 2. Let us look at this rectangle. One corner at 0, 0, 6, 0, 6, 4, 0, 4. So you can take any diagonal, bisect it, and you will get 3 comma 2. You can do it in any way you want, and suppose you call this C. Now with respect to the origin here, these are the coordinates. Suppose the axes are shifted. Let us make it more clear. Suppose this is the original small x small y coordinate system. Now we are designing a new capital X capital Y system. So the origin is now being shifted to 3 comma 2. So h comma k is equal to 3 comma 2. Let us find out the coordinates with respect to the new system. So capital X, capital Y, if we assume them to be the new coordinates, let us call this O, A, B, C. O dash is equal to 0, 0 minus 3 comma 2. So this gives minus 3 comma minus 2. So this coordinate, this point as seen from here will have coordinates like this. Similarly, A dash is equal to 6 comma 0 minus 3 comma 2. This will be 3 comma minus 2. Then we'll have B dash is equal to 6 comma 4 minus 3 comma 2, which is 3 comma 2. C dash is 0 comma 4 minus 3 comma 2, which is minus 3 comma 2. So these are the vertices of the corners of the rectangle as seen from the center of the rectangle, and you will find that all these 4 options are there in the list. Therefore all the options are valid. Question number 3. The point to which the origin has to be shifted to eliminate x and y terms in the equation 14x squared minus 4xy plus 11y squared minus 36x plus 48y plus 41 is equal to 0 is. Options 1, 2, minus 1, 2, 1, minus 2, minus 1, minus 2. The meaning of this problem is we must eliminate the first degree terms, the linear terms, and then if that has to happen, where should the origin be shifted? So what you do is use your theory. Small x is equal to capital X plus h, small y is equal to capital Y plus k, and substitute in that equation. Now all that you have to do is set the coefficient of capital X to 0 in the first case. Coefficient of x will come here as a 2ab term, 2xh into 14, so that becomes 28h and here you will have minus 4xk, so that is minus 4k, no x term here, and here you will get minus 36 is equal to 0. So you can reduce this as 7h minus k minus 9 is equal to 0. Again, in the second case, coefficient of y equated to 0. Again, you will have three locations. No y term here, but from here you get minus 4h. From here you will get 22k, and from here you will get plus 48. So if you reduce it, you will get 2h minus 11k minus 24 is equal to 0. So if you want the new origin, you will have to just solve these two equations. You can use the method of cross multiplication or any other elimination process. Minus 1, minus 9, 7, minus 1, minus 11, minus 24, 2, minus 11. So h by 24 minus 99 is equal to k by minus 18 plus 168 is equal to 1 by minus 77 plus 2. So h by minus 75 is equal to k by 150 is equal to 1 by minus 75. So hk is equal to 1 comma minus 2. Option C is the correct answer. Question number 4. The angle of rotation of the axis to eliminate the xy term in the equation 2x square plus 5xy plus 2y squared plus 5x plus 7y plus 1 is equal to 0 is options pi by 2, pi by 6, pi by 3 and pi by 4. Now we know this is a conic and the requirement is this xy term should vanish. If this term has to vanish, we have to rotate the system. The question is by how many degrees we must rotate in order to remove this xy term. There is a very important result which says that to remove the xy term, theta should be half tan inverse 2h by a minus b. This is a well-known result which will do a specific job of removing the xy term. In this question, a is equal to b is equal to 2 and 2h is equal to 5. A is the coefficient of x squared, b is the coefficient of y squared, 2h is the coefficient of xy. So applying this in the formula, this is half tan inverse, 2h is 5, a minus b is 2 minus 2. So theta is equal to half tan inverse 5 by 0. So this is 90 degrees and you will get the angle of rotation as pi by 4. Option D. Question number 5. The angle of rotation of the axis so that root 3x minus y plus 1 is equal to 0 transforms to y is equal to k is, the options are pi by 6, pi by 4, pi by 3 and pi by 2. So now this equation has to be transformed to y is equal to k. So let's go back to the orthogonal transformation. Cos theta minus sin theta, cos theta. So let's use that here. Small x is equal to capital X cos theta minus y sin theta minus of y is x sin theta plus y cos theta plus 1 is equal to 0. So let's collect the coefficients of x and y. Root 3 cos theta minus sin theta into x minus of root 3 sine theta plus cos theta into y plus 1 is equal to 0. Because this equation has to look like that, that means it must be free of the x terms. The coefficient of x must be equal to 0. So root 3 cos theta minus sine theta is equal to 0. So sine theta is equal to root 3 cos theta. Tan theta is equal to root 3. So theta is equal to 60 degrees or pi by 3. So the correct option for this problem is C.